How you going, guys? Kurtis from Cutting Edge Engineering. So today's job, we're going to be fixing the big lathe again. So even though we got this lathe for a very good price, it has given us its fair share of issues. It did come with a lot of electrical problems that we weren't aware of. The headstock is extremely noisy. And there are signs that it has been crashed. So we did sort out all of our electrical issues, and I did pull apart the headstock and replace a few bearings just to try and get rid of that noise. But there has been something going on ever since we've owned the machine. I did put it down to its overall quality and the style of the gearbox, and I have run a few of these in the past and they all had a very similar problem, which is the auto feed is difficult to get in and out of gear. It does seem a little bit tight, like something is binding, but because I've used these before, I didn't think any more of it until the other day when I was machining a very large cylinder rod. I went to take a cut, I put it into gear. As it was about to finish its cut, I tried to pull it back into neutral and it had jammed going forward. So I quickly hit the E-stop, backed out the tool post so I didn't wreck the job. Once everything had stopped and everything was clear, I did try to put the carriage into reverse and I wasn't able to get it in gear, and that's when I knew I broke something. There could be a few reasons as to what is wrong. It could be something as simple as a linkage or a pin that has come loose and is not allowing it to go in gear. There are also shafts that go from the joystick into the gearbox and they help select gears. It could be something like a roll pin has fallen out, or something is a little bit out of adjustment, or there could be something seriously wrong and something is broken. So before I tear this thing apart, there is an inspection plate underneath the tool post that we can open up and have a look inside to see if there's anything obvious. So you're probably wondering, why did we even buy this lathe even though it had all of these problems? When we got the lathe, we realized the issues were a lot worse than we first expected, but the deal was done and we just had to deal with what we got. And a lathe this size for that price doesn't come up very often here in Australia. If I was to try and buy a good high quality machine, it would set me back about $300,000. So we have made do with what we've got. We have done many jobs in this and this machine has definitely paid for itself, but we are looking at other options for the future. And I need to get this fixed because I've got customer jobs laying in the yard waiting to be done in this lathe. I've already drained the oil out of the apron to see if there was any metal particle in there that would indicate that there is a problem. We didn't find any, but now we've got a clear view of the bottom of the apron.
Ooh.
So after having a good look inside the apron and moving the gear stick in and out, I can see the gear set for the cross slide engages and disengages without too many issues. But what caught my eye, there is a linkage in the bottom of the apron and it runs up to the front of the apron and controls the gear set for forward and reverse. What I noticed with that, there is a gap between the two linkages and that pin could be working its way out and catching on something in the gearbox, but I'm not 100% sure whether that's the issue, so we're going to have to dig a little bit further. We're not going to be able to do any further investigation or adjustments from up here. We are going to have to take the bottom of the apron off so we can get to it.
What?
Oh no.
Uh-oh.
What is that? That's a front selector.
Oh, that's it there, okay.
But above it, up in there, see the corner of that cream thing? That's the other half of it. Damn. Oh, So we found what the problem is. It isn't what I thought it was going to be. I did think a linkage was getting caught on a screw on the other end of the apron, but this is the problem. What this does, this is the other end of the selector fork that pushes the gear sets in and out of gear. So obviously what's happened, fatigue over the years, and when I was doing that last job, it has finally broken. So we clearly found the issue, but I'm not going to disregard the pin at the start of the linkage. It is something I will look at once we get this fixed and make sure everything's working correctly. So now what we need to do is start removing parts so we can get that selector out. So the first thing we're going to do is remove this cover plate. What that does is hold in the spring clutch. That is a preventative measure so nothing gets damaged like the feed box or the apron if the carriage collides with something. O-ring's been smushed. It's at least it's strong. That gear won't go through that hole. Hang on, it's sliding.
Oh, there was a keyway holding it on.
Keyway. There's a gear. So that's our spring clutch out. Now we can see the rest of the damage and what we're going to need to do to get that selector out. I'm going to remove the hand wheel off the front of the carriage. I then need to remove the dial and see how that shaft is being held in place.
Oh.
Oh, that's tight. So with those two out of the way, now I need to remove these two plugs, and they hold in the selector shaft and the gear set. But before I can remove these plugs, I do need to remove this faceplate because they are covering the side of the plugs. But before I remove the faceplate, I need to remove the handle for the half nuts for threading. Now with that out of the way, before I can remove the plugs, I need to take out the tapered dowel pin that's holding that selector in place to let that shaft come out the front of the carriage.
Yay! Oh, where'd it go? Oh dear.
Oh, right there.
Ah.
Oh, I've got something else going on.
Aha!
There you go. Now we can get that shaft out.
Shaft is not moving.
There's a cam.
A cam?
It's cammed.
I don't know what that means.
That bit there.
Oh wait, what?
It's cammed.
Cammed.
But you can't get out of that. It's encapsulated in it.
There we go. Huh. Aha!
Now we can get that shaft out.
Oh, so that's fallen down.
Yep.
That's it.
Righto guys, so that's our broken gear selector. We've had a pretty good look at it, and as you can see, the dowel hole where the dowel pin goes through is quite elongated. That is just from over time it being loose, and it just slowly hammers out the hole, and finally it fails. So what we're going to do now, we're going to find a piece of material so we can make a new one. Drop it.
He loves the crocodile, eh?
Stay. Sit. 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 All the way. Pretty close. Stay. Stay. So to make our new part, I've got a piece of 25mm 300 grade flat bar. But I'm just going to take some measurements so I've got something to reference to, and then we can start machining. That's all of our measurements taken. Now we can get our plate set up in the mill. So I don't need to spend any time finding center or marking out the first hole location. I have plenty of material to work with. Providing I've got enough behind our 20mm hole, everything's going to work out. First thing I'm going to be using is a 19.5mm twist drill to drill out this hole. Now I'm going to change out to a 20mm Goering ream so we can finish that hole to size. Now that hole's done, I'm going to change out to a 50mm annular cutter so we can machine in that 25mm radius. And from our measurements, I know the distance between our hole centers is 85.8mm. Now we're going to change out our tool to a 45-degree face mill and machine this end down to size. Now that's milled to size, we're going to get it out of the mill so we can trace out the shape that we need to cut it to, and we're going to cut it by hand with a grinder. With the excess cut off with the grinder, I'm going to use my radius master to just clean up all the edges. So before we drill the holes, we do need to mark their location. It is going to be pretty tricky with this particular part because that hole doesn't correspond parallel with anything. And because they are elongated, it doesn't make it easy to find the center of them. We do have a little bit of room for tolerance here if it's not exactly in the right spot. So what we're going to do is set this up as best we can and then try and find the center of the dowel using the original shaft. And then we can scribe some lines in and check to see if they're right. Now I just need to touch off on the back edge using an edge finder so I can set a 0. Now I'm going to change out to a very small center drill and then line the center drill up with our scribe line. Because I can't start a twist drill on that sort of angle, I am going to use an 8mm carbide end mill to create a flat spot so I can start my drill. So with both holes center drilled, I need to drill and tap this end hole to an M6, and that is to hold in the dowel pin. Now what we need to do is drill the final hole for the dowel. However, it is a tapered dowel pin and I don't have any tapered reams that small, and I can't wait for one to be delivered or one to be ground for me. So what I'm going to do is measure the minor diameter of the dowel and the major diameter of the dowel, and I will drill the hole in the minor size, and then I will go to the larger size and drill the top hole. So this isn't exactly how I would like to do it, but I'm only working with what I've got here today. Because I'd like an interference fit on the holes, I am going to go one size smaller on the hole diameters for the dowel. So I'll be using a 7.9mm drill and then an 8.7.
Good.
Righto guys, so that is our new gear selector made. Considering that was a piece of scrap material and it only took an hour and a half to make it, I'm pretty happy with it, and it's a lot better than what we started with. Now what we can do is start putting the lathe back together. So that's the selector and the shaft in. Now what I need to do is hammer in the dowel. I have got very limited access in order to get to it, but I do want to avoid taking out this other gear set, which would give me more access, but I will be able to get to it from the top using this pry bar, and we'll just tap that into place. You got it?
Yep.
Am I on top of it?
Just.
Okay.
Yep. Yep.
Now that's in, I just need to screw in the locking screw and tighten it up. Before we can test anything, I still need to fit this shaft, which holds the cam bearing, in the correct position.
Ooh. So before we go any further on assembling the rest of the apron, we can now go through and make sure it engages and disengages forward and reverse. So making that new gear selector has definitely made a big difference. We can now engage forward and reverse. It is a lot better than it was, but it certainly isn't perfect and silky smooth. However, that could just come down to the age and the quality of the lathe and the rest of the linkage system in there, but that means we can now use the lathe, so we're going to finish assembling it.
Now that's all back together, before I refit the spring clutch, I am going to replace the O-ring on its cover plate because it is damaged. I'm also going to have a look at the linkage at the back of the apron and see if I can tighten up that linkage.
That washer fell out.
Now we got that out, I have got enough room I can put on an extra washer, and that's to get rid of the excess movement side to side when you put it in and out of gear. So now with all that back on, we're going to refit the spring clutch.
So,
Now I'm going to refit the cover plate at the bottom of the apron, and I'm also going to add a new layer of RTV sealant.
Hey.
Now all we need to fit is a cover for the inspection port, but before we do that, we need to fill it with oil.
There we go.
So now that's everything back together, we're going to give it a test run. Righto guys, so that has been a very successful repair. We've got all of our gears selecting, engaging and disengaging gears, and our rapid traverse also works in reverse, but we still need to be a little bit heavy-handed in order to get it into gear, but that's the way it was before, so I'm just going to have to put that down to it being an older, worn-out lathe. But now that we've got the lathe functioning, we can get back onto doing customer jobs. Hope you enjoyed the video. Thanks for watching.
Uh-oh.
So having a good look inside the apron, and I am going to use an 8mm carbide end drill because I want an interference, and I'm also going to deal with the linkage. Words are hard today.
This is not making sense.
How isn't it? There could be a few reasons as to what is wrong. So we've clearly found what the problem is, but
Oh, great.
now we can go through the process of testing to see if it goes in and out of first gear and everything.
Ew. Yeah, that's pretty gross. Oh, yuck.
Gear.
What? It can go up, can't it? No?
No, this gear's too big for this hole.
You can feel a bolt or what?
Yeah. You not see it?
Well, oh, yeah, I saw that before.
Oh. Thank you.
Are you going straight? Yeah, all the way through, right?
Yeah, all the way through. Then we ream it.
What the hell?
You can't turn the magnet off.
Oh no.
It's been
Don't
dropped.
just.
I need it.
It doesn't look. Can you fix it first before you put?
God.
Kurtis' pet. But you got to get the rest of the assembly out, do you?
No, now we can get this out. Yeah, I can leave that in there because we can get this in, then that back in,
Oh, okay.
and then that back in. So yeah, no, we're
So you didn't actually have to take off the cover plate.
No.
Let's go. What's over here? What's this? Come here. What's this? What's up here?